Assalamualaikum and hello everyone. My name is Nur Hamiza binti Muhammad Nordin from Alga Biomass Department and my supervisor is Associate Professor Dr. Koji Wamoto. The title for my final year project is Cultivation of the Gold Accumulating Alga, Galdieria sulphuraria using a liquified chicken feather by subcritical water treatment. For the introduction, chicken feather which made up of 10% of total chicken weight, becoming the most abundant poultry waste generated along with the rises in demand of the poultry production. According to Saravanan and Durai, chicken feather contains around 91% of keratin, 1% lipid and 8% of water. It also contains organic source which is up to 15% total nitrogen that can function as potential nutrient supplier. Chicken feather, which considered as a waste due to low in economic value, can be transformed and utilized into a value-added product, which is organic liquid fertilizer. Galdieria sulphuraria, which is the type of algae that is chosen in this research, is a type of unicellular algae that belongs to the Cyanida family of red algae. Galdieria has the ability to withstand the acidic condition, high temperature and metal-rich environment. Cyanidophyceae algae are also said to be able to withstand in metal-rich environment and can absorb high concentration of it from an aquatic environment due to the reason that metal can be easily ionized and dissolved in acidic water. According to Selvaratnam et al., among the Cyanidophyceae, Galdieria is shown to have the ability to tolerate a variety of environmental stresses and can produce a large amount of biomass, and it is beneficial compound which made it a suitable algae to be used in biotechnology process. Subcritical water treatment can be defined as a process of detoxifying and depolymerizing organic waste through balancing of pressure and temperature. Subcritical water maintains its liquid state at high temperature, range from 100 degrees Celsius to 374 degrees Celsius under high pressure. The water molecules that are about to evaporate will oscillate violently and causing a repeated collision which result to molecular bond of treated material to be ionized or electrolytically dissociated. The increase in the water temperature will cause the change on the dielectric constant and the ion product. According to Cheng et al., this unique characteristic of subcritical water that possess high ionic product and low dielectric constant, causing them to behave similar to a solvent such as methanol and ethanol. This makes subcritical water as a green extraction fluid that can be used for a variety of organic material. During subcritical water condition, the water molecules will act as an acid-base catalyst which will ionize into H3O plus and OH- to enhance the solubility of the chicken feather. It is said that the concentration of H3O plus and OH- in the subcritical water condition is higher compared to water ambient condition. Chicken waste disposal usually is handled differently according to the broiler farm or market. The difficulties and higher cost of disposing of the waste has led the industry side to choose a much simpler way. The most common way for the disposal of the poultry waste done by the industry is by simply throwing it or by burning it. These ways of disposing not only bring harm to the environment but also to our health. The issues are pollution in the air and water form, the production of harmful pathogen, landfill leachate, and odor release. The issue can be minimized by proper treatment for the feather waste. Utilizing the waste by converting it into valuable and useful product will add a major point in the sustainability part. Among the previous study, liquid organic fertilizer tends to be derived from fish bone, and there are only a few cases of organic liquid fertilizer being produced using chicken feather, due to the reason that chicken feather contains high amount of keratin like hair, which is quite hard to dissolve. In this study, after the successful conversion of chicken feather to liquid fertilizer, it will be used to cultivate algae to obtain biomass with it. However, the usage of this organic liquid fertilizer in a growth evaluation of microalgae seemed to have encountered the problem where not much study have been done into find out the proper concentration of nutrient required for the successful cultivation of algae. For the objective and scopes of this research, first is to analyze the micro and macronutrient that is suitable for the effective growth of Galdieria sulphuraria. For this objective, the cultivation of Galdieria sulphuraria was done using 3 different organic sources, which is glucose, peptide and chicken feather liquid, to compare which nutrient will result to a better growth of algae. The second objective is to find the proper conditions, such as the concentration of organic liquid fertilizer from the chicken feather to be used for the cultivation of Galdieria sulphuraria. The finding was done by using the same cultivation process but different ratio of alien medium to the liquified chicken feather to obtain different concentration of nutrient. The effectiveness will be observed through the growth rate or the turbidity. The methodology of this research will be divided into 3 stages. The first stage will be on the medium preparation. To prepare 2x alien medium, 3 glass bottles were prepared and labeled according to the organic sources used. The reagents then were weighed according to the amount listed at the table and were dissolved in 1 liter distilled water. 4.5 ml of chicken feather liquid was added to the dissolved reagent and the pH was adjusted to 2.5 using hydrochloric acid. Steps 1 until 3 were repeated by replacing liquefied chicken feather with 4.5 gram peptide and 4.5 gram glucose. All the mediums were autoclaved for 15 minutes at temperature 121 degrees Celsius and let to cool down at room temperature, and the cover was sealed to avoid contamination. For the research of second objective, the steps will be the same except for the amount of chicken feather liquid will be increased. The next stage will be the algae cultivation. 3 L-shaped test tubes were prepared and labeled as glucose, peptide and chicken feather liquid. 0.5 ml culture strain of Galdieria sulphuraria was added to the test tube using a pipette. 9.5 ml of 2x alien medium was added to the Galdieria sulphuraria strain. The tube then was plugged with a rubber stopper to avoid leakage and contamination. The culture was left for 6 to 10 days and was constantly shaken at 40 rpm on an orbital shaker with illumination of light at temperature 40 degrees Celsius. Steps 1 until 5 were repeated for 2 other medium. The last stage in this research is the growth analysis. The growth rate of the algae will be analyzed through the optical density. The growth of the culture was checked based on the turbidity at wavelength 750 nanometer using a spectrophotometer, Spectronic 20, Shimadzu, Japan. The reading were monitored every 1 until 3 days. For the results and discussion, based on the table and growth curve of Galdieria sulphuraria in 3 different organic sources, we can see that growth rate for Galdieria in a glucose-aided medium shows a better results when compared to peptide and also chicken feather liquid. Glucose recorded the highest growth rate at day 6 with reading of 0.997 nanometer. The growth rate show a better result for glucose might be due to the mode of cultivation chosen, which is mesotrophic. According to Lee et al., the specific growth rate and biomass production obtained through mesotrophic cultivation were higher compared to those obtained in autotrophic cultivation. One of the main substrates used for mesotrophic growth of microalgae are glucose, as it requires large amount of carbon, which is the synthetic carbon source. The chicken feather liquid, even though did show nutrient contribution to the algae, it is still very minimal. It is reported that previous study from Asmo et al., where the growth performance of each algae can be different from one nitrogen source to another. The next result will be on the growth curve of Galdieria sulphuraria in 3 different concentrations of chicken feather liquid. From the figure, we can see that Galdieria sulphuraria have a better growth in a condition that contain higher volume of chicken feather liquid. These results happen might due to the reason of the keratin content that comes from the chicken feather. The higher the volume of chicken feather liquid, the higher the presence of keratin protein as the carbon and nitrogen sources. It also causing the ability to obtain nutrients more efficiently in higher volume of chicken feather liquid. In conclusion, the chicken feather liquid does not show significant role in the growth of Galdieria sulphuraria compared to the 2 other organic sources, glucose and peptide. Even though that, chicken feather liquid still has the potential to be utilized as nutrient sources for algae cultivation if the proper condition can be identified before incorporating it to the cultivation process. Lastly, the conversion of feather into organic liquid fertilizer will result to profitability and sustainability of poultry industry and could be of practical interest in reducing the use of chemical substances. That's all from me. Thank you for listening to my presentation.